The topic is the most important topic in statistics and is the most confusing topic on statistics. Um, Not many people can understand it. Um, they they use it. They use it, but without really understanding. Um, so uh, I will let practice. Uh, I will spend the time working on it. Um, okay. Uh, Now you try to do some math extend. Say he claimed 60%, and he say show me, and he shoot 100, and he made 40. Now you calculate, assuming he is right. Assuming he is right. You give me just one tail. Maybe you feel. You give me the p-value. This morning he shoot 100. He got 40. You give me the p-value. Calculate it. Okay? This is already too messy. I erase it. Person C. Let me call this person C. Okay? I erase it. It's already too messy. Um, can you do it? Try to at least give me the Z score. At least give me the Z score. Remember the formula? Z. The standard deviation is here is the question. So deviation? What is the standard deviation? Okay, everybody make it standard deviation and this. Some student asked me, so what is the P? What the P should be? Because we assuming this is the truth. We assuming this is the truth. So we use 60% in P. Okay. We use 60%. The standard deviation is given says the fluctuation, showing the fluctuation. Okay, because P is not doing as expected, so we want to see the fluctuation. Um, according to this calculation. If the fluctuation is very small, and his today's performance is way out of the fluctuation. Let's say this is 60%, and the fluctuation is this much, up and down, okay? But his performance is way over there. You say, wow, the cold weather cannot explain this. But if the fluctuation is large, this is 60, and his performance is here, we say, okay, maybe that's true. Today is too cold. That you, so we claim. This is the purpose for calculating the standard deviation. All right. Do you get the number? Here is the number. Hold on. Oh, nice. So I do it here. N is 100. 0.6 and 1 minus 0.6 and point 6. I cannot see it. I cannot hear. Oh, okay. Point 063. Zero 489. Point 0.489. Did everybody get this? No. Yeah. S. Did I get this? Recheck. Recheck your calculation. Recheck your calculation. Yes. 0.0489. Okay. Anybody have a different? Huh? Okay, and to make our life easier, uh, yeah, this is running. Okay. Um, so this is a, okay, let's draw it. Let's draw it. And assuming that's him, okay, and one standard deviation away, what's here? What's here? Huh? That's the distance is this, okay? So it's 0.61. And the same here. And what's here? 0.55. Okay, once we get this, then we can get this. Okay, there's one unit of standard deviation away, one unit standard deviation away. This guy is a 0.4. Oh, so what's the next one? What's the next one? What's the 2 units? It's a 0.5. Okay? If we don't need this, but I just draw it. So this is 7. Okay? And keep going 3 units away. 3 units away. What's here? To save the space, I just use a 4, 5. So you said 3 units away. 3 units, 1 unit, 2 units. 3 units away. And he's aware, 0.4. He's even, so he is here, 0.4. Okay, he's here, 0.4. So the probability is very, very tiny. Which means if this is him, if he is as good as this, and this morning's performance is the probability is very, very small. It's very, very small. Let's get the exact number. Let's get the exact number. What's the z-score? What's the z-score? You calculated, I forgot, it's your question. I'm doing it for you. What's the z-score? Huh? You do it? Everybody do it? What's the z-score? Z-score is just calculating how many units away. How many units away from the center? It's just how many units away. This is 1 unit away. So this score is 1. This is 2 units away. So this score is 2. Here on the left is -1, -2. But in this question, sometimes it's not exactly 1 or -1. It's something like -1.33, something like that. So to calculate his performance, 0.4, we calculate the distance between his. I should make it red anyway. And the distance is divided by the standard deviation. Divided by the standard deviation. Okay. And this time, because the n is large, so this is small. The person C, this is a small. The person A, remember, is 0.1. The person B is 0.15. For person C, this is a small. That makes the difference. And this is a minus 0.2 divided by 0.05, which is a minus 4. Which is a minus 4. And you know when z is a 3, when z is a 3, when z is a 3, this small tiny part, this small tiny part is 0.3% divided by 2. Okay. This tiny part is 0.3% divided by 2. Because this plus this is a 0.3%. 68, 95, 99.7 rule, remember? 3 units away. The tail is very, very small. 3 units away. And this is a 4 unit. It's even smaller. It's even smaller. And our z table is only give to 3 point something. It's a 3 point something, okay? The z table is gives a 1, 2, 3, 3.9. Okay. This is a 3.09. Is only, this is a 3, okay? This is 0, this is 1 unit, 1 z square, 2 z square, okay? And our table so far only 3.1. For us, we are 4. We are 4, even though it's a negative 4. But this part and this part is equal, okay? This part and this part is equal. And it's very, very small. It's very, very, for 3.01, is already 0.499. Is already 0.499. This part is already 0.499. This part. This part is tiny, tiny. Okay. This part is very tiny, tiny, equal to this part. It's a very tiny, tiny. I think maybe it's 0.01%. It's very, very tiny. Which means that for our z table is out of the range. It's just very, very small. It's very small. It's very small. Very small. Very small. So for him, this is the probability for this. Okay. So if this is a true, he's shooting 100, only got 40% correct. This kind of event is the chance is very very small. Is maybe is 0.01%. It's a kind of lottery. It's a kind of lottery chance, which means no, this is unlucky. This is unlucky. We call it reject. In statistics, we call it we reject. We reject this. We say our conclusion. He is bragging. He is bragging. It's a very very small chance. To make this to get this a little bit more practice, and he said, show me, and he shoot 5 times, and he made it 2. He shoot 5 times, he made it 2, and it's 40%. It's 40%, and you do it. This is a person D. You do it. What's the standard deviation? What's the p-value? What's the p-value? The result will be different. The result will be different. Of course, this is next. What's the standard deviation? The standard deviation is just a value showing the fluctuation. Showing the fluctuation. This is why we need to calculate. So if the fluctuation is if his performance is within reasonable fluctuation, then we can kind of say, yeah, it's just randomly Is, but if his performance, this morning's performance, is way out of the fluctuation, then we say, wow, you cannot blame the weather. It's way out of the fluctuation.